Hey there, this is Dr. Rishi from the Learners Academy. Today we are going to talk about a topic called heights and distances. This topic is named as heights and distances in 10th ICSE and as applications of trigonometry in 10th CBSE. Under this topic, we study how we are going to utilize all the trigonometry that we have studied so far in our real life. Basically, in this topic, we are going to learn how to measure distances or how to find distances when angles and distances are given. In my first video, I had discussed about finding out the diameter of sun or the distance of sun from earth. This is how we are going to do these kind of sums. Today, in this topic, we are going to see how we can calculate a length of an object or height of an object which is kept at a distance from us, or how far the object is from us. Now, let us go ahead and discuss about heights and distances, or about finding heights and distances. There are 7 videos that we have made so far dealing with trigonometry. Link of all those videos is given in the description box. Please do like our videos, share them and subscribe to our channel, because I know there are a lot of students who are finding trigonometry difficult and I'm there to help them out. Now, without losing any time, let us go ahead and see how we are going to find the heights of distant objects, or how far the object is when we know the heights. Here we talk about 2 basic concepts. The first one is angle of depression and the second one is angle of elevation. So if I have say I have a person here, there are 3 things that we need to understand. So we have a person here and he is looking, say, at a tower up here. There is a flag at the tower and he's looking at the flag. Now, we are going to have his eyesight, the line which is parallel to the horizontal and passes through his eyes. This is going to be considered as the horizontal, and the angle that this line makes with the flag, this is going to be called as angle of depression. This is going to be called as angle of elevation, because we are elevating our eyesight. So I am looking above the horizon. So this line which is parallel to this horizontal line which is parallel to the ground would be called as horizontal, or the line of sight, and the angle that it makes to anything which is above the angle of sight is called as angle of elevation. The second concept that we need to understand is angle of depression. In this case, instead of elevating our eyesight, we are going to look down at something. So the observer in this case is on a platform. So we can have the most common example that they ask us: a person standing on a tower looking at a car going on a road first, or second, a person standing in a lighthouse, at the top of the lighthouse, looking at a boat. In both these cases, we will be using angle of depression. So let me quickly draw it for you and we will see how it looks. Now, let us consider a person standing on a tower. Please bear with my tower, it looks pretty funny. But yeah, we have a person who is standing on the tower and he is looking at a car which is moving on the road at the base of the tower. So the car can either go towards him or away from him, or could just be stationary. then the angle that his eyesight or the horizontal is going to make, which is going to be downwards, is going to be called as angle of depression. So I hope all of you have understood these two concepts, the angle of elevation and the angle of depression. So we are either looking up or we are looking down. In both the cases, we are going to make the angle. Now, these angles are basically equal to each other, because if you consider from the point of view of the driver in the car, this would be his horizontal and this would be his angle of elevation. Now, since the horizontal is going to be parallel to the horizontal of eyesight of this person, these two angles are going to be equal. So, the angle of depression for the guy who's standing on the tower is going to be equal to the angle of elevation for the guy who's sitting in the car and looking at the tower. Now, let us go ahead and see how we are going to use trigonometry to find heights of distant objects if the distance is known, or distance of the object if the heights are known. In 10th standard, majority of the sums are either dealing with finding the height of the distance or finding the height of the object, that is a tower or maybe a pole or maybe a lamp post or maybe a flag post, and the distance from the flag post or the tower, the distance of the person from the flag post or the tower or the antenna, whatever the scenario. So if we draw our triangle, you will see that we either have to find in this triangle, if I have A, B and C, B is a right angle triangle, then we are majoritarily going to find either AB, that is distance from the observer. So my observer would be at A and my object would be at B when we are talking about angle of elevation. And if it is angle of depression, then my observer would be at C and my object would be at A. Now in both these cases, we are either trying to find out value of AB or value of BC. So effectively we are going to use two ratios majoritarily in all these cases, that is cot theta and tan theta. That is tan theta and cot theta. These are the two ratios that are going to be used majoritarily. However, there would be few sums that might ask you to find the hypotenuse. Now the sums, majority of these sums would be like a person is flying a kite and we have to find the length of the string that is there. In that case, the kite would be up here, the person would be down here, the angle of elevation would be given. That is the only case where we would be using sine, cos, cosec or sec. So if whenever you are solving this, the first thing that you need to understand or the first thing that you need to figure out is which side you have to find. If it's AB or BC, then absolutely you are going to go ahead and solve it using tan or cot. However, if AC gets involved, you can use sine or cos. Now let us go ahead and see some examples from various books. We are going to start with the easiest examples. According to me, the easiest examples this year are given in the CBSE book. There are slightly difficult examples in state board book, and then the maximum difficult examples are in the ICSE book. So first we are going to do few sums from the CBSE book, then a couple from the state board, and then a couple more from the ICSE book. The first example that we are going to take today is from NCERT book. The chapter name is Some Applications of Trigonometry. It is solved example 3. The question is as follows. An observer 1.5 meters tall is 28.5 meters away from a chimney. The angle of elevation of the top of the chimney for her eyes is 45 degrees. What is the height of the chimney? Now in this case we have an observer here and she is observing a tower. Her height is 1.5 meters. So this is 1.5 meters. She is observing the tower. So her height is taken as the height of her eyes, and the angle of elevation is taken to be, now here we have a tower like this, which has a top up here. Here the angle of elevation is taken as 45 degrees and the distance between the person and the tower is taken as 28.5 meters. Now let us consider this, or let us draw a triangle using the information that is given to us. So we have the person's eyes at point A, then we have point B is the ground, parallel side to the horizontal. So I can write this as C and D, and then I have a tower up here which is making an angle of 45 degrees, and I'll call this as E. Yeah. Now if you look at the figure, it is 28.5, this is 1.5. So my AB is 1.5, my BC is 28.5. Now we have to find the height of the towers. That would be CE, so it would be AB plus it would be CE, so it would be CD plus DE. Now if you look at this triangle, if I hide this and if you look at this triangle, we can conveniently say that this length AD would also be equal to 28.5 meters. So just by looking at the triangle, I can say that tan 45 degrees is equal to, so tan 45 would be the opposite side, ED upon AD, or ED is equal to AD multiplied by tan 45 degrees. Now from our table, we remember that tan 45 degrees is equal to 1. So I can say that an AD is equal to 28.5 meters. So it's 28.5 meters multiplied by 1. So the total length of ED would be 28.5 meters. Now the length for CE is the height of the person, that is CD plus DE. So it would be 28.5 plus 1.5. So that would give us 30 meters. And this would be the height of the tower. So if you've seen, it is a very simple funda to understand how to get heights of a distant object if the distance is known. This is one of the most easiest examples that we see for grade 10. Let us increase our complexity by seeing the next example. Now let us go ahead with the next example. A tree breaks due to a storm and the broken part bends so that the top of the tree touches the ground, making an angle 30 degrees with it. The distance between the foot of the tree to the point where the top touches the ground is 8 meters. Find the height of the tree. Now here what we have is, we have a tree. Say suppose, let us consider the tree to be the straight line, and it breaks from somewhere here and then it falls down like this. Now this is making an angle of 30 degrees with the ground, and it touches 8 meters away from the base. So this is the base of the tree, this was the top, the storm came, it broke it down, and it is making an angle of 30 degrees. Now we can directly name the angles here itself. I'll have it as ABC. Rather, I'll have it as ABC, B being the right angle triangle. Now I'm keeping B as the right angle triangle because we've used the same convention for last 6 videos. It is easier for students to get it if it is repetitive. So now from this I need to find the entire length of, say, BD. Now what would be BD? So BD will be equal to BC plus CD, but the CD is equal to CA. So I can say that it is equal to BC plus CA. Now, so if I am able to find the value of BC and then the value of AC, I can pretty much find the total length. So first I will write tan theta is equal to, now I'll use tan theta to find the value of BC. So I'll get BC, it is opposite side, tan theta is opposite side upon adjacent side. So it is BC upon AB. So therefore BC will be equal to AB tan theta. In this case theta is 30 degrees and AB is 8 meters. So it is 8 meters multiplied by tan 30 degrees is 1 upon root 3. Tan 30 degrees is 1 upon root 3. So I'll use it as 1 upon root 3. So it is 8 by root 3 meters. Now for AC I can use, since I have the adjacent side, I can say that cos theta is equal to AB upon AC. So therefore AC is equal to AB upon cos theta. In this case AB is 8 centimeters, so it would be 8 divided by cos 30 degrees. That is going to be 1 by that is going to be a root 2 or root 3 by 2. So cos 30 degrees in this case is root 3 by 2, which gives us 16 upon root 3. So now we have 8 upon root 3 and 16 upon root 3 as our answers. So my BD is going to be equal to 8 upon root 3 plus 16 upon root 3. That gives me 24 upon root 3. Now as a thumb rule, we know that the denominator can never be a irrational number. So we will have to multiply it by root 3. So we'll multiply the numerator and the denominator by root 3, giving us the final answer as 24 root 3 upon 3, which is equal to 8 root 3. This can further be solved by taking the value of root 3. However, for CBSE this is a good enough answer. So we will say that now we'll complete the answer by saying that the length of the tree or the height of the tree is equal to 8 root 3 meters. Now let us go ahead and take few examples from 10th State Board. Now this is a solved example from a 10th State Board book. This is example number 2 under the section Applications of Trigonometry. The example is like this. From the top of a building, an observer is looking at a scooter parked at a distance away, makes an angle of depression of 30 degrees. If the height of the building is 40 meters, then find how far the scooter is from the building. Now here we have a building that is 40 meters tall and the observer is up here and he is observing a scooter which is parked here, and it's making an angle of depression of 30 degrees. Now if this angle is 30 degrees, then this angle would also be equal to 30 degrees. This is my right angle triangle here. I can say it is ABC. My BC is 40 meters and I need to find my AB. So if you look at the figure, it is pretty clear that I can write tan 30 degrees is equal to BC upon AB. So therefore AB is equal to BC divided by tan 30 degrees. Now obviously before you write the sum, you will also have to write let us consider, let the given problem be depicted in the following figure. This is the first statement that you would always write whenever you are solving these kind of sums. Now I am not doing it because it would just be too much of work to write all these things and it would make the video unnecessarily long and boring. So I am trying to make sure that I am solving the doubts in such a way that you will understand it in the easiest possible manner. So here we have AB is equal to BC upon tan 30 degrees. Now we know that BC is equal to 40 meters and tan 30 degrees is equal to tan 30 degrees is equal to 1 by root 3. So therefore I can say that AB is equal to 40 degrees upon 1 by root 3. So that would effectively be 40 multiplied by root 3 by 1. So that's equal to 40 root 3. Now the value for root 3 is 1.73. So you can always write it in the form of, now this is specific to state board. They generally give the value. CBSE is happy with the root values. ICSE even stretches it further, gives values of even values of angles that are not in the first 5 that we have studied. So it would be 40 multiplied by 1.73, giving us the final answer as 69.20 meters. So that is how far the scooter is from the building. Now let us take this a notch higher and see an even more complicated example. This is taken from 10th ICSE. The example is as follows. Two people standing on the same side of the tower in a straight line with it measure the angles of elevation of the top of the tower as 25 degrees and 50 degrees respectively. If the height of the tower is 70 meters, find the distance of two people. Now let us depict the given example. We have a tower here and then we have two people standing. One is here somewhere, one is here somewhere, and they are making an angle of 25 degrees and 50 degrees. So this guy here would make an angle of 25 degrees, angle of elevation, and this guy is making an angle of 50 degrees. Now the height is given to be 70 meters. We will name them as say A, B, C and D. Now we have to find the distance between the two people. This is something special that is taught to ICSE and not to state board or CBSE. ICSE does teach students to find the values of angles that are other than 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. In such a scenario, there are two things that ICSE does. They either provide tables. So we have logarithmic tables and so these kind of tables come. These kind of tables are printed, which have printed values of the sine, cos and tan of all the angles from 0 to 90 degrees printed in them. Or at some instances, ICSE just gives the value. So they'll give you what tan 25 degrees would be and what tan 50 degrees would be, and the student is expected to find the final value. Now, let's see what we have here. From this figure, I can say that tan 25 degrees is equal to AC upon, tan 25 degrees is equal to CD upon AC, that is opposite side upon the adjacent side. Now I have to find the distance between the two people, that is AB. So the easiest way to find it is AC minus BC. So I have to find both AC and BC. So first I will try to find AC. AC will be, therefore AC can be written as CD divided by tan 25 degrees. CD in this case is 70 meters and tan 25 degrees. So I'll write the values here. Tan 25 degrees is equal to, and tan 50 degrees is equal to. So tan 25 degrees is 0.4663 and tan 50 degrees is 1.1918. Both these values I found out from the tables, the trigonometric tables that we get. These tables are available in the stationery shop, so in case you are curious, please go ahead and buy them. They don't cost a lot. However, they do give you a lot of information. So in this case, I will replace tan 25 degrees by 0.4663. After doing the division, I get the value as 150.11. After doing the division, I get the value as 150.15.12 meters. Now let's go ahead and find the value of BC. So BC is equal to, so we can write tan 50 degrees is equal to CD upon BC. So that, therefore I can write CD is equal to, so I can write BC is equal to CD divided by tan 50 degrees. So that is 70 divided by 1.1918, giving me the final answer as 58.74 meters. Now I have got approximate values. If you use a calculator, obviously the values would vary. So we have to find the value of AB. So I can write AB is equal to AC minus BC. That gives me 115.12 minus 58.74 meters. So that would be equal to, so after doing the calculations, we can find out that it is equal to 150.12 meters. We'll do exactly the same thing with tan 50 degrees. So I'll say tan 50 degrees is equal to CD upon BC. So therefore BC will be equal to CD upon tan 50 degrees. So that would give me 70 divided by 1.1918. After doing the calculations, I find that this is approximately equal to 58.74. Now I have to subtract my BC from AC to get my final answer. I need to find AB. So AB is AC minus BC. So that is 150.12 minus 58.74, giving me the final answer as 91.38 meters. So this is my final answer. So the distance between A and B is going to be equal to 91.38 meters. This was all for today. I know it's a very lengthy video. However, we have still not dealt with the most complicated sums that appear in the board exams for 10th CBSE, State Board and ICSE. This is going to be our second last video in this series of videos on trigonometry. The last video is going to deal with only the most complicated sums that have appeared in the board exams. So stay tuned. Please share these videos with all the students who find trigonometry difficult, and feel free to comment your doubts in the comment section so that I can help you out with them. This was Dr. Rishi from the Learners Academy, signing out. Thank you.